Burnout is often characterized by feelings of exhaustion, cynicism, and reduced professional efficacy. Brain fog, while not a formal medical term, describes a state of mental cloudiness, difficulty concentrating, and forgetfulness. Though frequently discussed together, the relationship between these two conditions is complex and involves overlapping physiological and psychological mechanisms. Let's explore the current understanding of how prolonged stress can lead to these states. The human body's stress response system is managed by the hypothalamic pituitary-adrenal axis, or HPA axis. When a person perceives a threat, this system triggers the release of hormones like cortisol. In the short term, cortisol is beneficial. It increases energy availability, sharpens focus, and prepares the body for a fight-or-flight response. However, chronic stress, a key driver of burnout, can lead to the dysregulation of this system. When the HPA axis is persistently activated, the body is exposed to high levels of cortisol for extended periods. This can have widespread effects. For instance, some research suggests that prolonged cortisol exposure can impact the prefrontal cortex and the hippocampus, two brain regions critical for memory, learning, and executive function. The prefrontal cortex is responsible for planning, decision-making, and moderating social behavior. The hippocampus plays a major role in consolidating information from short-term to long-term memory. Alterations in these areas are thought to contribute to the cognitive symptoms known as brain fog. Individuals might experience difficulty organizing their thoughts, remembering new information, or staying focused on a task. These cognitive difficulties are not isolated. They are often accompanied by the emotional and physical exhaustion that defines burnout. Another key component is inflammation. The stress response is intrinsically linked to the immune system. Acute stress can temporarily boost immune activity, but chronic stress may promote a state of low-grade, systemic inflammation. Inflammatory molecules, known as cytokines, can cross the blood-brain barrier and affect brain function. Elevated levels of certain cytokines have been observed in individuals reporting symptoms of fatigue and cognitive impairment. This neuroinflammation can disrupt the delicate chemical balance in the brain, further contributing to feelings of mental sluggishness and poor concentration. Neurotransmitters, the chemical messengers that allow brain cells to communicate, are also affected by chronic stress. Serotonin, dopamine, and norepinephrine are crucial for mood regulation, motivation, and alertness. The relentless demands of a high-stress environment can deplete or disrupt the normal functioning of these neurotransmitter systems. For example, a reduction in dopamine activity can lead to a state of anhedonia, or the inability to feel pleasure, which is a common feature of burnout. Similarly, imbalances in norepinephrine can affect attention and focus, compounding the experience of brain fog. Metabolic changes also play a role. The brain is an energy-intensive organ, consuming about 20% of the body's total energy, primarily in the form of glucose. Chronic stress can interfere with the body's ability to regulate blood sugar levels, leading to fluctuations that can affect cognitive performance. When the brain doesn't receive a steady supply of energy, functions like attention and processing speed can be compromised. This can manifest as the mental fatigue and reduced clarity associated with both burnout and brain fog. Sleep disruption is another critical factor. Stress and worry are common causes of poor sleep, and the relationship is cyclical. Lack of restorative sleep impairs the brain's ability to clear out metabolic waste products that accumulate during waking hours. One of these is beta amyloid, a protein that can interfere with neural signaling. During deep sleep, the brain's glymphatic system is most active, flushing out these toxins. When sleep is consistently poor, these substances may build up, contributing to cognitive decline and the feeling of being mentally stuck. This sleep deprivation also exacerbates the physical and emotional exhaustion of burnout, creating a reinforcing loop of fatigue. The psychological dimension of burnout is equally significant. A prolonged mismatch between an individual's workload, sense of control, rewards, community, fairness, and values can lead to a state of learned helplessness and emotional exhaustion. The feeling of being trapped in a stressful situation without any perceived way out can be mentally draining. This cognitive load, the constant worrying, ruminating, and attempts to cope consume significant mental resources. This leaves fewer resources available for other cognitive tasks, such as problem-solving, creative thinking, and memory recall, which is a direct pathway to experiencing brain fog. Furthermore, burnout often leads to behavioral changes that can worsen cognitive symptoms. A person experiencing burnout might withdraw from social activities, reduce engagement in hobbies, or adopt poorer dietary habits. Social connection and engaging activities are known to be protective for cognitive health. Their absence can lead to a less stimulating environment for the brain, potentially compounding the effects of stress and fatigue. It is helpful to view burnout and brain fog not as separate issues, but as intertwined manifestations of the body's response to overwhelming, prolonged stress. The physiological changes, hormonal dysregulation, inflammation, neurotransmitter imbalances, metabolic shifts, and sleep disruption create the biological foundation for the symptoms. The psychological experience of cynicism, detachment, and a lack of accomplishment then interacts with these biological changes, creating a complex state of mental and physical depletion. Understanding these interconnected pathways is a key step. The cognitive symptoms of brain fog are not simply a matter of not trying hard enough. They are rooted in tangible changes in brain function and chemistry driven by an overloaded stress response system. Similarly, the exhaustion of burnout is more than just feeling tired. It is a profound state of energy depletion affecting the body at a cellular level. Clinical experience suggests that these states are signals that the body's capacity to cope has been exceeded. The body's systems, from the HPA axis to the immune response, are pushed beyond their limits of resilience. Effects vary between individuals, as personal history, genetics, and support systems can all influence how one responds to chronic stress. The observable symptoms of burnout and brain fog are the external expression of these internal struggles for equilibrium.